Definite integral is an area with geometric figures. Alright, what an integral does, again, is it finds the area between the curve and the x-axis. Okay, so I have this function x minus 1, designated by this purple line, from 1 to 4. So I want to find the area between the curve and the x-axis between 1 and 4. And it forms that triangle, right? Let me darken that in a little bit. Okay, so I want to find the area of that triangle. Well, the area of a triangle is base times height divided by 2, sometimes said 1/2 base times height. Okay, well the base goes from 1 to 4, so the base is 3, and the height is 1, 2, 3. So this integral is 1/2 base times height, so 1/2 of 9, or 9/2. And this is done because often we want to do things the simplest way possible, and it would be easier to find the area using a simple geometry formula than sometimes to take the antiderivative and evaluate it. Alright, so I have this line x plus 1, and I'm going from 1 to 3. So there's 1, and there's 3, and I have this shaded in region right here. Okay? Let me make that darker. Okay, so there's my shaded in region. And you can see that shape there is a trapezoid. Okay, and trapezoids are often used in calculus. So its base 1 is 2, its base 2 is 4, and its height, which goes in this direction, is 2. And the area of a trapezoid is 1/2 base 1 plus base 2 times the height. So I can do base 1 plus base 2 is 6, half of that is 3, times 2 is 6. So the area of that figure is 6. Or that integral is 6. Okay, let's look at a couple more. Okay, number 3, I have this semicircle shape here. See, I'll shade that in with my pen. Okay, and a semicircle is 1/2 the area of a circle, so 1/2 pi r squared. And you can tell that the distance from here to here, the radius is 2. So that means this integral that goes from -5 to -1 is 1/2 pi r squared. So 2 squared is 4, half of 4 is 2 pi. Okay, number 4 is absolute value that goes from 0 to 6. So 0 to 6. And we can see it's just a big triangle, right? So, again, the area of a triangle is 1/2 base times height. So let's see, the base here goes from 0 to 6 is 6. The height is 3. So 6 times 3 is 18. Half of 18 is 9. So that integral is 9. Well, what happens if they don't give you a picture? They give you nice pictures. Well, let's consider those. Let's look at number 5. Well, I can sketch a graph. So I've taken courses before this one, and I get the function y equals 2, if this is the x-axis right there, and that's the y-axis. And I want to go from -2 to 3. Well, that's a nice rectangle, right? Well, the area of a rectangle is just the base times the height. Well, the base goes from -2 to 3, so that's 5, and the height is 2. So the area would be base times height, or 10. So that integral is 10, and I haven't really had to use any calculus to do it, just some basic elementary school geometry. Okay, let's look at another one. Well, this here is a semicircle. Okay? And it's a semicircle with a radius of 5. And it would go up here through 0, 5, and here through 5, 0, and here through negative 5, 0. Okay? And so the area of a semicircle is 1/2 pi r squared, and my radius is 5, so 5 squared is 25, half of 25, 25 over 2 pi. Okay? And again, 2 more. Number 7, 2 minus the absolute value of x plus 1. Okay, so I'm going to rewrite that function down here. Y equals negative absolute value of x plus 1 plus 2. That means my function is translated left 1 and up 2. So left 1 up 2. So that'd be my vertex, and it's pointing downward. Okay? Now I would just need to figure out where those points are. Okay? Well, I know my integral goes from negative 3 to 1, so let's see what happens. Okay? Well, if I plug in negative 3 into the function, I get negative 3 plus 1 is negative 2. Absolute value of negative 2 is 2, but I have a negative sign, plus 2 is 0, so 1 comma 0. If I plug negative 3 in, I get 0 as well. Okay, so it's that triangle. So the triangle, the base goes from negative 3 to 1 is 4. The height goes up to 2. So the area of a triangle is 1/2 base times height. So 1/2 4 times 2, which would be 4. So that integral evaluated is 4. Okay, and the last one. Okay, this function here is a line. So it goes through 0, 2. And it has a slope of negative 2/3. So it goes down 2 and right 3. Okay, and I'm evaluating from 0, that's 3 comma 0. I'm evaluating from 0 to 3, so it's that triangle. So the base of my triangle is 3, the height is 2, so my area of my triangle is 1/2 base times height, so 1/2 of 2 times 3, so half of 6 is 3, so evaluate that integral is 3. And so this is a very good technique. I had a college professor once who said in a grad class, well, if you can do something a simple way, why do it a complicated way? And that's always stuck with me. Well, good luck.